Hello students, welcome back. In this video, we'll begin building our survivor-based reactor control game, Corefall. We're going to focus on two primary things here in this lesson. First, our world. What is our world going to look like? What's the mood that we want the person playing our game to feel as they play Corefall? And secondly, we'll design a player, something the user can control within that world. How will we move through the world and interact with the objects that we will place in our game? So let's head right over to the computer screen and dive right in. So I've got a browser open right here, and the first thing that I'm going to do is go to vscode.dev. And once I'm here, we'll use this web-based IDE. Of course, if you have an IDE installed on your computer, you can use one of those as well. We will open up our folder for Corefall. So I'll head to my desktop, which is where our folder is downloaded to, and I'll open the entire folder right here. We'll allow this, and we can see we have all 8 lessons open here that we will use for the sequence of these videos. We're in lesson number 1, so I will open that folder, and I have the final version of this lesson and the starter version. The final version is there for you to reference in case you got to go back and double check or look at some of the lines of code that we've worked on, but the starter version is what we are going to edit together. So we have that open. I'm now going to minimize my screen, and I'm also going to go directly to the Corefall folder on my desktop and open this lesson directly. So we'll open lesson 1's starter file in the browser, because now any changes that I make to my code here will be reflected in the browser. Okay, so let's take a look at this game in its current state. It's pretty broken. It's pretty bad. I've got this little teeny tiny player in this world that is just a slew of purple. Everything sort of blends in. My player can move horizontally, but does it extremely slow. Does not move vertically at all. I don't like this. We need to put some work into it. So let's head over to our IDE, or Integrated Development Environment, and look at what we have here. And before we get into writing any lines of code, let's overview what this file actually is. So this is an HTML file, and if you look here, we start with this first line, doctype HTML. HTML is the language of the internet, and since we're making web-based games, this is going to be the file that we use. And a lot of stuff lives inside of this HTML document. You don't really need to know much about HTML, but a nice little thing here is that it consists of these things called tags. And a tag is something that is inside angled brackets. So I have an HTML tag, a head tag, a meta tag, a title tag. And one thing about tags is you open a tag and you close a tag. So we'll have opening tags that start and closing tags that end. Most tags do that. And then we put information inside of the tag. So right here you can see that this says Corefall. So if we change the information inside of a tag, so I don't know, maybe I'll just say, let me save the changes. I'll just say the art of doing CS. Now, when I refresh the page, if you look up here, right, I got this tab that says Corefall. If I refresh the page, changing the HTML content changes information about the page. It says the art of doing CS. Now, I'm going to change that back. I'll just do a nice little Control-Z to put that back to Corefall. And we've got other tags here in our HTML document. We have a script tag. Notice we're opening the tag, we're closing the tag. A script tag is going to be especially important for us because this is where we will put the JavaScript programming language. We can write lines of JavaScript inside of a script tag. But here, we're not actually writing any JavaScript at all. Instead, we're bringing in an external library of JavaScript code into our program. We're bringing in some extra functionality, some pre-written code. And the library that we are bringing in is called the P5 library. And this is a really great library for us because it allows us to render graphics to the screen. Graphics that we're going to use to like render or draw our little player right here, right? This little guy, or our background, or this text that's on the screen, or these shapes that we have. The P5 library helps us do that. Now, if we go a little bit further, we've got a style tag and a body tag. And then if you look here, we've got another script tag. So this is where we open the script tag, and let's just see where we close it. We go all the down to the end here, and there we close that script tag. This, in between these two opening and closing script tags, this is where we will write our own JavaScript code for our game. So if you look, these are all the lines of code that are currently in place for our game that we see right here. So let's go through and look at what we have inside of the script tag. So we start. We've got our game and our lesson number and the scope of our lesson, our world and player. And then what we have is a mission checklist. And so each lesson is going to consist of 8 missions that we will solve together. And through this process, we are going to take a terrible, terrible game. And if you forgot, this is our terrible, terrible game state right here. Really, really ugly. And we're going to turn it into a better, more playable version. And along the way, we're going to learn a lot about programming and game development. But before we get into solving these missions, let's see what else is in this file. So if I scroll down a little bit, we have something called the student edit zone. And then look, it tells us it is safe to modify values within the student edit zone. So here we have a lot of different variables that we can just simply come in and change. We can change their numbers. And by changing the numbers, we are going to be tweaking parameters of our game. Our game will play different. It will look different. It will feel different. And anytime we change one of these values in the student edit zone, our game will not break. All right. It's just going to change how it plays. But note, there's an end to the student edit zone. So anything outside of this student edit zone, if you start changing things, and we will have to change things outside of this zone, but if you don't change them correctly, you could potentially break your game. So we have to be extra careful out here. So it almost looks like we're sort of defining data, right? We're defining variables. We're defining some other variables. And then what do we have? We have these things called functions. Functions are going to be extremely important for us here. Think of a function as like a pre-written section of code. And so if I wanted to do the same thing in my program over and over and over again, I might have to write those lines of code over and over and over again. But another way I could do it is I could write the lines once and put them inside of a function. And then when I want to run these lines of code, I only have to run this particular function. And so let's look at what some of the functions we have. We have a setup function, a draw function, reset game to defaults, update player, get input direction, draw scene, draw background, draw goals, draw player, and draw HUD. So it looks like the scope of our functions, let's just think about this for a second. We've got like these drawing functions, right? So that's sort of important. We got to draw stuff to our screen. And then I also have like update functions. We have to update values. And we're really going to try to hammer home this idea that game development is really 3 different layers all working together. The first layer that we're going to approach is defining our data. So we have to define our data, right? Here's all our variables that we'll define. Once the data is defined, as we play our game, we have to update that data. And so we have functions like update player that's going to work for us here. And once we've updated the data, we have to make sure we draw those changes. So we have functions that are going to draw or render graphics to the screen. All right, this is wonderful. This is great. So the last thing I'll say before we get into our missions here is that some of these functions I had to write for us. So like the draw background function, I wrote that function. But some functions exist automatically for us. In particular, I'm going to tell you that there is a default setup and default draw function. Where did those default functions come from? They came from the P5 library that we imported or brought in. And really quick, this is important. The setup function runs automatically once when we load our game. So when I hit refresh and I load my game, this function automatically gets run. The draw function also runs automatically, and it runs every single frame of our game. So anytime we want something to occur over and over and over again, like updating our player or drawing all of our graphics to the computer screen, we can call that. All right, with all of that said, a nice overview of our HTML file that we have here, let's dive into our missions. So if I look up here, mission 1 says we got to change the background color of the reactor chamber because right now it's this ugly, ugly purple. I agree, super ugly. I agree with myself. Now, one of the things I'm going to teach you first, if you hit Control F, it will open up your search bar over here. Again, if you close that out, it is Control or Command F if you are on a Mac. And this is going to be powerful for us because we can search for specific phrases in our code now. I'm going to search for mission 1. See, mission 1 is a tag. In the mission checklist, it's listed right here to change the background color of the reactor chamber. But if I hit the down button, it will move to the next match of the tag. And the next match is the mission that I am looking for. We are looking to target the background color. Observe how it affects the mood of the overall world. So I have a constant variable called BG color. And then it's set to this weird value. Let's break this whole line down right now. First, where does this line live? If I scroll up, it lives in the student edit zone, which means we are safe to edit this. Changing this variable is going to only change how our game plays, feels, or looks. Now, const, what in the world does that mean? Well, a constant is a variable that once it is defined within its own scope or where it lives in our program, it will never change. So when I run my program, I define my background color, it is set to this. It will never change once I run the program. That's what it means to be a const or constant variable. Now, the way we indicate that something is a constant variable is we typically use all capital letters, which is why this says BG underscore color, all in caps. Now, over here, I have a value inside of quotations. Anytime you have something inside of quotations, this is known as a data type known as a string. And this string is a hexadecimal string. It's actually representing a specific color. What indicates that it's hexadecimal is this little hashtag or pound sign out in front. And a hexadecimal string for a color is actually 3 colors mixing together. It is red, then green, then blue, all mixing together. You get 2 digits representing red. You get 2 digits representing green and 2 digits representing blue. Now you might be sitting there saying, wait a minute, I thought a digit was the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And you would be absolutely correct. That is in the decimal number system. In the hexadecimal number system, which is indicated by this pound sign, we actually have the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then get ready, A, B, C, D, E, and F. So what exactly do those letters represent? Well, A represents 10. B represents 11, C is 12, D is 13, E is 14, and F is 15. So what happens when you go past F? Well, what would you do? Well, just like here, when we ran out of 9, we moved to 10. So the next number in hexadecimal is 10. What does that represent? Well, it represents 16. Hexadecimal is a base 16 number system, okay? Now, in our 2 digits that we have, that means red could go from 00 all the way to FF. In hexadecimal. What does that mean in terms of number values, decimal values? Well, 00 is 0 in decimal, and FF is a value known as 255. So let's just mess around with this. So imagine what happens if I change the red portion to be FF. Well, that means give me the maximum amount of red that you have available to you. And then if I set the green portion to 0, that means give me no green. And I set the blue portion to 0, that means give me no blue. Let me delete my little comments here so I can actually run this. And now let's refresh the page. Whoa, I broke it. Oh, it's probably because I have these comments here too. Let's refresh the page now. Hey, look at that. We got a nice red background. It's not the color I want at all, but we're building an understanding of how color works. Let's change the red channel to 0, and let's bring the green channel up to FF. So we'll say, give me all the green. Refresh the page. 00 FF 00. That should reload. There we go. And so look at that. We get a super bright green. Well, what if I lowered these values? So like what would be lower than FF? Well, let's do like AA. It should be a darker green. And if I do, I don't know, like 6, 7, what's this going to be? An even darker green. All right, well, what if I bring in a lot of blue here? So let's raise the blue channel. All right, so now we see more blue. What if I bring everything in? FF, FF, FF. So give me all the red, all the green, all the blue. Hey, it's white. All right, so when you mix all of our colors in equal proportion, you get white. What if I mixed 0, 0, no red, no green, and no blue? What would this be? Well, it would be black. All right, so hopefully you have a decent understanding of what we are looking at when we talk about color in terms of a hexadecimal string. So now let's actually go through and let's set the value of the background color. So I'm going to set it to have, let's see, 0, 7 in the red, 1, 1 in the green channel, and 1 F in the blue channel. That's the color I'm going to pick. So if I set this, it's kind of like a dark navy blue. Maybe you like that. Maybe you don't. You have the freedom here to set this color to be whatever you want it to be. But mission 1, in my opinion, is done. Congratulations. So let's move to mission 2. The way we're going to do that is we're going to come up here. If you still have this open, you can access it. If it's not open, just hit Control F to open your search bar and type in mission 2. We are going to increase the grid spacing to change the chamber layout. All right, so let's hit the down arrow to go to the next instance of this tag. Increase the grid spacing value. Watch how the chamber layout changes. So right now, this variable, again, it's a constant, so that once I define it, we won't change it. It's set to 20. And that is going to define the width of our grid spaces. I don't know, let's set it to something like 100. Changing that, ooh, our grid changes. But this just looks ridiculous right now, I think. I think with our teeny tiny player and our grid spacing being so big, I don't like that. And I'm never going to have the player be that big. That would just be crazy. I'm going to cut it in half. So let's set the grid spacing to 50 and see how this looks. All right, I think that looks pretty good. What do you think? Maybe you're going to keep it here at 50. Maybe you're going to change it, make it a little bit different. Well, I think what would help us decide how this looks is changing the player's size. So let's look at mission number 3. Mission number 3, if we look at the tag, oh, perfect. We got to target the player technician and make them a little bit larger. Because if we look right now, what is their size? Their size is set to 15. Well, let's just be funny. Let's set it to 200. Make it gigantic here. Whoa! Super big player. All right, just dominating the game window. We don't want that at all. And so what we're going to do is we're going to shrink that player back down. So let's shrink it down to a reasonable size. I'm going to set mine to be 35. And we're going to make note here that the player's shape is a nice rectangle, and that rectangle is going to help us later on when we try to do things like interact with other objects. We're going to be able to detect collisions nicely given this rectangular shape of our player. Hey, mission 1 done, mission 2 done, mission 3 done. What is mission 4? All right, mission 4, we got to change the player's visual identity. We're going to change the player's core color. Give this technician a better look to it. Because right now, if we look here, what do we got? We kind of got 2 parts to our player. We got this like white exterior and then this core color here as our green. Maybe you like that green. I don't think I do. So I'm going to change that. And so it's going to be stored in a variable called player core color. And let's see if we can figure out how we're going to make this. I want it to be like a lot of green and a lot of blue mixed together, which is going to be like a nice cyan color with just a little bit of red. So if I'm going to do just a little bit of red, I'll do 3B for a little bit of red in the red channel. I want a lot of green, so I don't know, I'll do something like E7. And you can do lowercase letters here or capital, it doesn't matter. And then I want all the blue. Give me all the blue. So for all the blue, that would be FF. And so if we think about it, we got lots of green, all the blue, and only a little bit of red. So mixing green and blue, we should get like a nice sort of, oh, that's really nice. That nice like light cyan color, which matches really well to the darker blue background that I have of the battlefield. Hey, mission 4 complete. Mission number 5. We totally got to increase the player's speed because right now they are just moving unbearably slow. It's not fun at all. And I think the purpose of games, right, is to be fun. I think the purpose of learning how to code games should be fun. So hopefully you're sitting there going, this is pretty entertaining. I really like what I'm doing. I feel like I am creating things all on my own. Would you look at that? Player speed is equal to 1. No wonder why they're moving so unbelievably slow. Let's speed them up. 27. I don't know. Is that going to be a good number? Probably not. Let's just see how fast. Whoa. This is too fast for me. Too fast for me. I am going to slow us down. Let's pick a reasonable number. Let's just do 5. We're going to be like 5 times as fast as we were. Let's just see what we got. Okay, I feel like that's pretty decent. It's hard to tell, though. And the reason why it's hard to tell is because I'm stuck to moving only in the X direction. My vertical movement right now is unfortunately broken. Hopefully, mission number 6 is going to have us deal with that. All right, let's look at mission number 6. Hey, my wishes came true. It says add vertical movement using the same pattern. Support WS or up and down keys. All right, in order to maybe solve this mission, we got to get context to where we are. See, all of our previous missions, we were just defining data. But now we're moving on to the next phase. We're moving to update the data. Remember, game development is 3 layers all working together. It is defining your data, updating your data, and then drawing or rendering that data to the screen. So right now, we are inside of a function called getInputDirection. Okay, so we're inside of this function. What exactly is this doing? Well, first, inside of this function, we are defining 2 variables, dx and dy. But if you notice, they're not defined as const. They're defined using let. And the reason why we're using let here is because within this function, we are going to change their values. These variables are not going to be constant at all. In fact, dx is shorthand for a change in an x value. dy is shorthand for a change in a y value. And let's look at what we have right below. Our first example of something known as an if statement. An if statement is a way for us to ask a question to the computer. Here is the question. It shows up inside of parentheses. If that answer to that question is yes, or also known as Boolean true, a true value, then whatever code we have here will run. If the answer to this question is no, or Boolean false, a false value, then this code will not run. So let's look at the question that we are asking. We're asking if key is down 65, 2 vertical bars, key is down left arrow. Well, let's start with this part that I got highlighted here. I hope that this kind of makes sense. We're asking, hey, is the key down? Is the left arrow key down? Okay. 2 vertical bars is logical or. So we're asking, is it one of these things or is it this? Okay, one or the other. Only one has to be true. And key is down 65. Every key on your keyboard has a numerical key code, and 65 is the code for the A key. So this question right here that we're asking if the A key is down, if we're pressing the A key, or we're pressing the left arrow key. So if one of those things is true, what are we doing? We're changing dx to be -1. We're saying, hey, dx is equal to 0, minus equals 1 says subtract 1 from it. Well, what's 0 minus 1? 0 minus 1 is equal to -1. So dx gets a value of -1. When we talk about horizontal movement, a negative value is typically to the left, right? It's to the moving left on the number line. So we're moving our character to the left. We have another question. if key is down 68 or key is down right arrow, what are we doing? Well, we're going to take that dx variable and we're going to add 1 to it. So what is 0 plus 1? It's 1. That indicates that we are moving to the right. And if we look, the key code of 68 is for the D key. So we're checking to see if we're pressing D or the right arrow key. And then we're moving to the right. This works, and it works well. We're seeing the horizontal movement working correctly, but what we're not seeing is that vertical movement. So we need to map a similar system for the vertical direction. So I'm going to ask 2 more questions. I'm going to say if key is down, and then I just need to know the key code. I don't know what key code I'm going to use. Or key is down, and then we'll type up arrow. Up arrow. There we go. Now, left arrow, right arrow, up arrow, and down arrow are special keys that have defined names that we can just reference here. All right, so if the answer to this question is yes, then what are we going to do? Well, we want to move the character up the screen. So I'm going to target dy. Now, this is going to make you a little mad if you don't know it, but that's okay. In the x direction, to the right is moving positive and to the left is moving negative. In the vertical direction, going up is moving negative and going down is moving positive. And the reason why is we define this upper left-hand corner of our game window as 0, 0. We increase in x values going to the right. We increase in y values going down. So if I want to move up, I have to set my dy value to -1. So we'll say dy minus equals 1. Now, we got to just make sure we get the right key code. So if I think about this, like the typical arrow key movements work good, but then you also have W, A, S, and D. So we want to put the key code in here for W. The key code for W is 87. Hey, all right. So now we should have upward movement. Let's check it. Oh, I refreshed my page. I didn't mean to do that. Let me open up my folder again. Hopefully my changes are still in here. Oh, perfect. It changed. So now if I refresh the page, I can move left and right. Let's see if I can move up. Hey, I can move up. That's really, really good. Perfect. All right, so I moved up nicely. Now we got to add downward movement. So let's ask one last question. If, all right, now here's our question. Key is down. The key code for the S key is going to be 83. Or, so 2 vertical bars, key is down, and we'll put the down arrow. Then what do we want to do? If that question evaluates to yes, we're going to take dy, we're going to target that dy, and we're going to add 1 to it. All right, let's check if our input is all set up. Refreshing the page, I got leftward movement, I got rightward movement, I got upward movement, and I got downward movement. And the nice thing about this system is I also can move diagonally, so I can move all around. Wonderful, wonderful. Mission number 6 is complete. Now, before we go to mission 7, let's just see, what are we doing here? This next line says return, and then we put these things inside of curly brackets, and it says dx and dy. So this function is returning something. That's kind of interesting. What is it returning? Where is it returning to? Well, if I go up just a little bit, so above the get input direction function, inside of the update player function, the first line here is calling that function that we were working in, get input direction. So when we call this function runs and it gives us back or returns those dx and dy variables that we were editing. And so right here, we're getting those dx and dy values, and we're storing them in this variable called move direction. So I now have access to them inside of another function. And that is the power of return statements, which we will certainly see moving forward. But right now, mission number 6 is done. So let's move to mission number 7. Oh, look at that. We are in a function called draw goals. So now we're on to that third layer of game development, drawing our data or rendering our data. See, we defined data, we've updated data, and now we got to draw some data. So right now, if you look at our goals are just these kind of curved rectangles. They don't got much flair to them. What we are going to do is we are going to add a glowing frame around each of these goals or containment ports because they're going to contain our nuclear material. We're going to use stroke. We're going to use stroke weight. We're going to use no fill, and we're going to use rect. We're going to learn a lot here about how we can draw to our canvas. Before we get there though, let's just backtrack a little bit. We're calling this we're writing in this function called draw goals. Where is this getting called from? So if I scroll up just a little bit, there's this function called draw scene. And inside of this function, I'm calling 4 other functions right now. I'm drawing my background, I'm drawing the goals, I'm drawing the player, and I'm drawing the HUD. See, if I comment one of those out, right? If I just like put 2 vertical lines there to comment that out, if I run this now, the background's gone. Oh man, my background. If I comment this out, my player will be gone. Oh man, there's my player. Where'd he go? We have to actually draw this information to the screen. Now, where is draw scene being called? I'm going to zoom all the way up to the top of my code. Well, top-ish of my code. We said at the beginning of this video, we have 2 really special functions that are brought in by the P5 library, the setup function and the draw function. This setup function runs once at the start of your game. This draw function runs every single frame of your game. It just keeps getting called over and over and over again. And look at what we're doing. We're updating the player. So that's like my movement system is going to work, that movement system that we fixed. And then we're calling draw scene. So every frame of our game, we're updating our data, we're drawing our data. We're updating our data, we're drawing our data. So that's a pivotal and crucial understanding. So let's go and actually draw a little bit more data. So what is stroke? Well, if you look here, we call no stroke, and then we call fill, and then we call rect for our goals. And if you look at what our goals currently look like, they kind of just look like they're a filled in rectangle. So stroke, when you draw a shape, imagine you're drawing a shape on a piece of paper. You have a marker, okay? I grab a red marker and I draw a rectangle. You are going to see the outline of that rectangle in red because that is the color of the marker that I used. No stroke means give me an invisible marker so you don't see the outline. We then call fill. Think of fill like a paint bucket. You put a color of paint in your paint bucket, and then that paints in the shape that you are about to draw. So here, I'm using an invisible marker, and then I'm filling it with a certain color. And then rect is a function that will create a rectangle for us. It takes the x coordinate of the top left point and the y coordinate of the top left point, and then the width and the height. And then this is here for rounded edges, and we're going to talk about that for a second. So that gives us this nice sort of shape right here. Like watch what happens if I get rid of the 8, right? If I get rid of the rounded edges, you can see now they're just square rectangles. All right, so I'm gonna put that back. Okay, so we want to now use a similar feature here, but to create like a border around our rectangle. So to create the border, I'm going to call stroke. Instead of no stroke, which was give me an invisible pen, I'm going to say, hey, I want a pen or a marker of a specific color. And the color that I'm going to pick is going to be, let's see, goal frame color. Where was this color defined? It was defined way up in our student edit zone. If I scroll down a little bit, I got a bunch of different colors that we can look at. And you can see I have goal frame color right here defined. All right, now you might be looking at like goal fill color and you say, well, wait a minute, this is another color. This looks a little bit different. We'll talk about this. This is an RGBA string or RGB alpha. Essentially, this is what I use for when I want to have a color that has some transparency, meaning you can sort of see behind it. And you can kind of see behind this color. I'm sure we'll talk more about that in future videos. But now that we know that we have that variable, I can use it as the color of my marker for the shape that I'm about to make. We also have a nice function called stroke weight. I can change the thickness of the marker. So I'm going to double its thickness and make it 2. And now I don't want any paint in my paint bucket. So when I draw this next shape, I don't want to fill it in because I don't want to overwrite what's already here. So to empty your paint bucket, you use no fill. And now we are set to actually draw a rectangle. So I'll call the rect function. And I'm going to, let's see, the x position and the y position of the top left corner. I used goal.x and goal.y. I'm going to use the exact same thing here. So goal.x, goal.y. And then I want the width and the height. Well, I'll use goal.width and goal.height. The exact same thing I had earlier. So goal.width, goal.height. And then let's just set the rounding to be 8 because I want this to sort of match up exactly like I have for the goals. So let's see if we see that pop of color now appear. Hey, look at that. That looks really, really pretty cool. It kind of matches like my player's vibe. I like this a lot. All right. Now, the last thing I got to do is mission number 8. So let's head back over here and let's change our tag to mission 8. Mission 8 is all about text in our HUD, or our heads up display. Our HUD is this region right up here where we can display text to the user about information of the game. And so the first thing we're going to do is we got to change this to actually be the title of our game. Right now it says game name. We're going to change the game title text to give your version a custom name. Before we do that, let's just look at what's happening in this draw HUD function. We're calling no stroke, which says give me an invisible marker. And then we're filling our paint bucket with our HUD's background color. If you notice, the HUD's background color is an RGB alpha string. It's basically black, 0 in the red, 0 in the green, 0 in the blue, but a transparency of 0.7, which means let me slightly see behind it. And then we're drawing a rectangle whose top left corner is 0, 0. That's right up here. And then its width is the width of my canvas, and its height is a variable called HUD height, which I have set to 60. So it makes that rectangle all the way across and then brings it down. And you can sort of see behind that. Awesome. Let's see what happens next. We change the paint in our paint bucket to be our text color, and then we align our text. In the horizontal direction, we're left aligning it, and in the vertical direction, we are center aligning it. And we set the text size to be 18. With the properties of our text set, I can now actually display some text. I can render the text. This is going to take 3 pieces of information. First, the text that you want to render. I don't want to render game name. I want to render the actual title of my game, which is Corefall. Then we have the position of the text, the X position and the Y position. So right now at 15 and 25, I think that's perfect. Hey, look at that, 15 and 25. But if I change that, let's change the X coordinate to be 150. It should shift to the right. So let's see. Pops to the right. Very good. And let's change the Y position to be 500. Remember, the bigger the Y value, the further down the screen you are moving. And so now it's 500 pixels down. Of course, that's a really bad place for it. Let's get it back up into the HUD. So just Control Z gives me that. And if I refresh my screen, I have a much, much better version of our game than what we started with. That very ugly and unplayable starter file is now much more pleasing to look at and a lot more fun to play. This is a great place to stop here. So I'm really happy with all of the great work that we did in this video. We implemented our world, we implemented our player, and we got a really nice overview of our HTML file and what we have to work with, whether we use it to define data, update data, or draw data to the screen. I hope to see you in our next video.